Hello everyone, welcome back to another episode on Microsoft Azure. And in this episode, we are going to focus on Azure Compute. You need Azure Compute because it offers the essential infrastructure for running your application efficiently. Azure Compute allow you to tap into the cloud-based computing capacity, providing scalability on demand. It supports containerization for easier deployment and management of the application. Azure Compute facilitate the deployment for both Windows and Linux virtual machines, which you can call VMs, offering flexibility for diverse workloads. With comprehensive support for hybrid environments, you can deploy application how and where you want. Azure Compute includes a robust identity solution ensuring management, endpoint protection, and secure access to on-premises and cloud apps. It enables easy migration of VMs to the cloud, simplifying the transition processes. With pay-as-you-go pricing and the Azure hybrid benefit, you can deploy great applications while saving the cost. Creating a virtual machine on Azure can be a straightforward task, but it can be also quickly become complex depending on your infrastructure requirement and your configuration. It is crucial to be mindful of the resource provision for you to ensure efficiency and cost effectiveness. Provisioning a VM on Azure is as simple as few clicks in Azure portal, or you can execute few command lines through the Azure CLI. However, the complexity arises when you start considering factors such as CPU, memory, storage, and network options. These are the few keywords, very common keywords, which you're going to hear very often, and those are going to be the cores. This comes from the CPU, and then it is temporary storage, storage optimize, hyper-threading, virtual CPU, GPU, memory, constraint vCPU, generation, SDD, SSD, and all these options, the configuration varies when you change the generation of the VM, the series of the VMs. So we will explain what are these common names and how it impacts your cost and the performance for the VM. Before we dive in further, it's important to familiarize ourselves with the CPU employed in Azure Compute. Microsoft utilizes various types of CPU across its services and virtual machine offerings, catering to different workloads and performance requirements. Microsoft collaborates with several hardware partners to provide a diverse range of CPU options. Some of the key CPU types commonly used with Azure includes Intel Xeon, Intel Xeon processors. Azure VMs often features Intel Xeon processors, which are widely recognized for their performance, reliability, and scalability. These processors are available in different generations, offering varying level of performance and capabilities. AMD EPYC. These are the processors known for high core count, memory bandwidth, and performance for virtualization and cloud workload. You can also consider these are the alternative to the Intel-based VM. ARM-based architecture, that is in addition to the traditional x86 architecture, Azure supports ARM-based processors such as from Qualcomm and other vendors. ARM-based VM instances are optimized for a specific workload, including IoT, edge computing, and microservices offering power-efficient computing solutions. Another type of processors are going to be FPGA, and FPGA stands for Field Programmable Gate Array. Azure offers FPGA based acceleration services such as Azure FPGA and Azure machine learning services with FPGA, enabling customers to accelerate specific workload such as AI, cryptography, data processing using hardware acceleration. NVIDIA GPUs, these are the processor basically equipped with virtual machines to do the specific task, and that task can be like machine learning, AI training, graphic rendering, and other compute intensive workloads. Let's try to make it more interesting and try to understand single threading, multi-threading, and hyper-threading concept. In a single threaded application, instructions are executed one at a time in a single sequence. And in multi-threading, the CPU can switch between the threads rapidly, allowing it to execute instructions from different threads in parallel. So you can see this is my CPU. If it is a single threaded, it can handle only one instruction at a time. If it is multi-threading, that means if these two threads are coming, the CPU will switch between these two threads so quickly, so it will look like it's just working in parallel. However, it becomes more complex when we talk about hyperthreading. In a hyperthreading concept, each core can handle two threads. That's why it gives you double the number of vCPUs. So for example, how do we calculate it? If it is a hyper-threaded environment, it means if you have 8 cores and each core can handle 2 threads, that is going to give you the total 16 virtual CPUs. Let's talk about the storage now. Azure offers several type of disk tailored to different performance, durability, and cost requirement. The options you are going to get under the managed disk are going to be the standard SSD and premium SSD. Standard SSD provides a balance of performance and cost effectiveness for a wide range of workload. They offer consistent performance and are suitable for general purpose application. However, when we talk about the premium SSD, they do deliver high performance, low latency storage, optimized for input output, intensive workload such as databases, big data analytics, and virtual machine disk requiring high throughput and low latency storage. The next option you get is Ultra Disk. Azure Ultra Disk are a new category for high performance storage designed to meet the most demanding performance and latency requirement for mission critical workload such as SAP HANA databases and high performance HPC applications. They offer sub-millisecond latency and high throughput with customizable performance option. The next option is going to be the shared disk. Azure shared disk allow multiple virtual machines to share a single disk, enabling scenarios where such as clustering, high availability configurations, and share file system, shared disk support, both standard HDD and premium SSDs. You can still go for HDD type of storage. However, you will be compromised when it comes to the performance. And I'm not going to talk about unmanaged disk since those will be retired by September 30, 2025. Now, let's talk about the final topic for this episode, which is going to be the single root input output virtualization technology for networking, which is known as SRIOV. If you have noticed, during the early virtualization, there was a virtual switch, which is part of your physical infrastructure. And then on top of that, you are running multiple NICs. And these NICs are associated to the VMs. So you have VNIC 1, which is associated with the VM1, VNIC 2 is associated with the VM2. And then you have the physical NIC When it comes to sending traffic out, it is going to cross this virtual switch. And that's how the limitation comes, because it is going to consume a lot of CPUs and other resources from the existing hardware. With this technology, SRV IOP, what has happened, they bypass virtual switches and you are going to have the virtual functions. Those are associated directly with the VNIC. So VNIC 1 is associated with the virtual function 1, VF2, that's how they share the physical NIC infrastructure and provide you the line rate of speed. Thank you for watching and I will see you in the next video.